Hi, my name is Enrique Manji, and today I'm going to be explaining some basic concepts of cavitation. And I'm going to be doing so by showing off a little trick. For this trick, all you need is a bottle and some water. You want to fill the bottle to about here, right here. And then all you have to do is hit it right here, and the bottom will break out. So I got a hammer because it was a little hard to just do with my bare hand. So we're gonna try this. All right, so as you can see, the bottom of the bottle broke out when I hit the top of it. This actually took me a few tries to do. But yeah, that's the trick. So why does this happen? In a popular YouTube video by Repcord titled Voodoo, How to Break the Bottom Out of a Bottle, in this video he claims that this works because 1. Air is compressible while water generally isn't. He says that striking the opening rapidly will compress the air, exerting a pressure on the water, in turn exerting a pressure on the bottom of the bottle, therefore breaking it. He also claims that more water means less air needs to be compressed. Now, this explanation actually is incorrect. But why is it incorrect? Well, if you look up the standard pressure you need to break a bottle, it's between 50 to 60 psi. In order to exert this amount of pressure on the bottle, you would need to be compressing 3 liters of air into the bottle, which obviously isn't what you're doing, because you can't do all that with just your hand. Also, the amount of water or air in the bottle actually wouldn't matter if this explanation were correct. And one more thing is that this trick actually works with the cap still on. So I have another bottle here with the cap, it's twist on, so it's tightly sealed. So that means no air would be compressed when I tried breaking this bottle. So let's see if it works. Okay, so as you can see, I've now filled the bottle with water up to here, and I've put the cap back on. It's tightly sealed, nothing's dripping out. So we're gonna try to break this bottle. That broke a little too much. Okay, so I'm actually doing this one again because it worked a little too well the first time and it completely shattered the bottle. Take 2. So as you can see, the bottle still broke with the cap back on, proving that the explanation from before was incorrect. So what's really happening? Why is this bottle breaking from the bottom when you hit it from the top? Well, from the title of this video, you can obviously tell that the real answer is cavitation. Now, what is cavitation? It is the formation of an empty space within a solid object or body. It causes the formation of vapor bubbles in a liquid due to the liquid boiling at normal temperatures when the pressure drops too low too fast. The word cavitation was first coined by R.E. Froude and first cited by Barnaby and Thornycroft in 1985. It was first thought up, however, by Euler in his theory of water turbines in 1754. Actual cavitation, however, was first discovered by Barnaby and Parsons in 1893 when they were investigating one of their ships, the HMS Daring, which wasn't going as fast as they wanted to, and when they looked into it, they found that it was these tiny little bubbles acting on the turbines, which was lowering the efficiency, causing damage to these turbines. So yes, cavitation happens in turbines because as the turbines are spinning, they create a low pressure region behind them, therefore creating this cavitation. And when these cavitation bubbles burst, they cause damage to the turbine, just as you saw with the beer bottle. Cavitation can also be seen in siphons. Here's a picture of a siphon right here. And if the siphon gets too high, then the pressure will be too low, causing the water to boil and vapor bubbles will form, making the siphon not work. So some fun facts about cavitation as well are that some animals, particularly sea creatures, use cavitation when they attack, such as the mantis shrimp and thresher shark. Now, you're probably wondering, okay, I understand this, but what does it have to do with the beer bottle breaking? Well, first, I want to show you a little experiment. And all you need for this experiment is a syringe and some more water. Okay, so as you can see, I've got a syringe and I filled it with a little bit of water. Now what you want to do is seal off the entrance so that no air can get in or out, and you want to quickly pull back on this part, and you can see the formation of little vapor bubbles in there. You can see that. So when you're pulling it back, you're actually creating a low pressure region which makes the water vaporize. Get all those cavitation bubbles. Okay, so I took a couple of different shots of the syringe, and as you could see, when I pulled back, vapor bubbles started to form because I had closed off the entrance. Therefore, when I pulled it back, I created a low pressure region which vaporized the water, thus making cavitation. So how does this relate to the bottle? Well, when you hit the bottle, the water inside the bottle actually stays there while the bottle moves down. So it's kind of like the syringe. The water stays up there while the bottle moves down, creating a low pressure region at the bottom of the bottle, vaporizing the water, creating cavitation bubbles. And so when those bubbles collapse, all the energy from the bubbles is released on a concentrated point, making a spike in pressure and temperature, creating a shock wave which breaks the bottom of the bottle. Here's some high-speed images that I got from the internet to show this better. The bottle breaking, and that's it. That is cavitation.